Good morning, everyone. I wanted to walk through the final assessment that I've given you so that you know what I expect of you in terms of completeness. So to begin with, it contains a total of 4 problems and they're each worth 5 marks, so it's a total of 20 marks. It's important that you understand whenever you use a formula that comes from your formula sheet, you should write the formula down, you should show the substitution with the units. You do not need to explain anything about any formula that you pull from your formula sheet. If you are going to use that formula to calculate something, as long as you show the formula, show your substitution with the units, and show the result with the proper units, then that's fine. However, if you use a formula that does not come from your formula sheet, so this would be a formula that you build. Maybe it's a formula that you build based on adding forces together. Or maybe it's a formula that you build based on equating a net magnetic force with a centripetal motion. Then you need to explain where those formulas come from. So the bottom line is if you're going to use a formula that you build, you have to explain how you built it. Other than explaining those formulas, I do not want to see any explanations for problems 1, 2, or 3. However, part B of problem 4 specifically asks you to explain something, so obviously I'm going to expect an explanation for part B of question 4. And an explanation means in word form. Same as it's always been for anything that I've marked, your work has to be clear, it has to be organized, and it should be easy to follow. What I've done is left every second page blank in this assignment. You may need that extra space. You may not need the extra space. It depends on your approach to how you're solving these problems. So all of your work needs to be submitted to me no later than Friday, June 19th at 3:15. And late submissions are not going to be accepted. So if it's later than that, I'm not going to be marking it. I'm giving you lots of time, basically almost 2 weeks to complete these 4 problems. There is no reason why you can't find time in 2 weeks to do 4 problems. I know you have other courses. I know you have other commitments. Some of you have jobs. I know you have other commitments at home. But this is part of your responsibility as a student, is to organize things so that you do get them done on time. So that's the bottom line with the expectations. Now I want to walk through each of the problem sets just to remind you of some things. Problem number 1 has a red curling rock hitting a blue curling rock, and although it doesn't say in this question, the only way that you're going to solve this problem is by applying the law of conservation of momentum, which is not on your formula sheet as a formula, so whatever you do is going to require an explanation. I will remind you, though, that when you talk about the law of conservation of momentum in 2 dimensions, you cannot just say momentum equals momentum plus momentum. You have to either draw a completed vector diagram or resolve all of the momenta into vector components so that you can use momentum horizontally before equals momentum horizontally after, and momentum vertically before equals momentum vertically after, and go from there. This is going to be a problem that may require you to go way back in your notes. This is from the first unit to look at how it's done. For the most part, though, I think as long as you understand that momentum is a vector, and when you use conservation of momentum, you need to consider that, you should be okay here. Number 2 gives you an electron that's moving, and it's going to enter the region between 2 parallel plates, and in that region is also a magnetic field. Now what that means is when the electron enters that region, it will experience a magnetic force due to the magnetic field, and it will also experience an electric force due to the electric field that's between the 2 plates. And the question asks you to determine the magnitude and the direction of the acceleration of the electron when it first enters the field. So I don't want to do this question for you, but I will tell you that as soon as you see acceleration mentioned, you have to think net force. And the net force that's going to be acting on the electron will be a sum of the electric force and the magnetic force. Now, how is it you're going to add the electric force and the magnetic force together? Well, I guess it's going to depend on the directions of those two forces. If the magnetic force acting on the electron is in the same direction as the electric force acting on the electron, then the net force, which you can set equal to ma, would simply be found by adding those two forces together on your calculator. You would have to add the magnitude of the electric force and the magnitude of the magnetic force. If, on the other hand, the electric force is in one direction and the magnetic force is in the other direction, then what you would do to find the net force is you would take the larger of the two forces as a magnitude and subtract the smaller of the two forces. As an example, if I had an object, and the directions I'm going to give you here in this illustration have nothing to do with this question, I have an object and an electric force is acting on it east, and it's 100 newtons, and a magnetic force is acting on it west, and it's 140 newtons, then you would take 140 newtons minus the 100 newtons to get 40 newtons, and the direction of the net force would be west because the magnetic force was greater and it was the magnetic force that was west. So in order for you to determine the magnitude and direction of the net force so you can find the net acceleration, you need to determine the magnitude and direction of the electric force, and you need to determine the magnitude and direction of the magnetic force. Now, to determine the magnitude of each of those forces, you would use a formula. To determine the direction is going to require an application of a concept which would require some explanation. So even though you're not calculating something, you still should be explaining how you're getting a direction. That's part of what I'm expecting here. Once you know the two directions of the two forces and you know the magnitudes of the two forces, then you should be able to determine the net force. And once you know that, you should be able to determine the instantaneous acceleration as a magnitude and a direction. All right, question 3. There's not much I can really say here, just a few little hints. You're talking about electron diffraction here, so you're going to be interested in applying the concept of de Broglie wavelength for the electrons. And since you also have an interference pattern and the properties of the interference pattern are given to you, then you can also apply Young's double slit formula for double slit interference. And you're going to have to try to sort this all out. You're also asked to determine the accelerating voltage, so it looks as though you're probably going to have to apply conservation of energy in terms of potential difference. And that's something we've done dozens of times in this course. The first part of this question asks you to determine the binding energy per nucleon for a particular isotope. I think this question is pretty straightforward. The piece of advice that I would give you, however, is because there are so many digits involved here, in order to make sure you get the right answer, be very careful when you enter them into your calculator. And the last part of the final question asks you to write the decay equation for the beta decay of calcium-48 and explain how you arrived at all of the numbers in the decay equation. So in, I believe, Monday's lesson, we talked about radioactive decay and we applied decay equations for alpha decay and for beta decay. So this is something you should already know how to do. And that's it. That's the best I can do in terms of getting you set up for success with this assignment. The rest of it is in your hands. You need to sit down, you need to concentrate on this stuff, go back and review a few things. I will not be answering specific questions about any of these problems. If you want to be crafty about it and ask me general questions, then I would be happy to help you out. Anyway, I hope that gave you a little bit of guidance in terms of what I expect, and I hope that it helps you do well on this assignment. Have a great rest of the day, you guys. We'll talk to you later.